Hope my screen is visible. So today we are going to discuss about this Navy Bayes algorithm. We'll see how this algorithm works. The uncertainty associated with events chosen from some universe of events. Okay, so actually, see for example, the probability everyone you might have studied already, right? That is when tossing a coin. So, what's the probability of occurrence of head or tail? So, okay. So, based on that, okay, we take some decision. So, the universe consists of all possible outcomes, and any subset of these outcomes is an event. For example, the die rolls one, or the die rolls an even number like that. Okay, notationally, how we represent that is probability of E means the probability of that particular event E. Okay, and probability theory is used to build so many models, and also this probability theory is used to evaluate models, and also this probability theory is used all over the place. Okay, and this probability is not new to you, already you might have studied from your school. Okay, and we'll see what do you mean by dependence and independence. Assume that there are two events E and F, and these two events E and F are dependent if knowing something about whether E happens given us information about whether F happens or not. Okay, otherwise they are independent. So I hope you understand the statement. So there are two events E and F. Okay, so when can you say that this E and F are dependent is if knowing something about E happens. Okay, so for example, if you know that if E occurs, okay, so that if that gives some information about whether F happens or not. Okay, so in that case, now this E and F are dependent, and similar vice versa also. That is, if you know something about F, based on that you can predict the occurrence of E. In that case also you can say that the event E and F are independent. Otherwise you can say that these two events E and F are independent. So for instance, if we flip a fair coin twice, knowing whether the first flip is heads gives us no information about whether the second flip is head. These events are independent. Okay, you can't say that when you're flipping a coin. Okay, so since the first event is head, you can't say that the second event may be tail. You can't tell like that. Okay, so in that case, these two events are independent. On the other hand, knowing whether the first flip is head certainly gives us information about whether for both flips are tails. If the first flip is head, then definitely it is not the case that both flips are tails, right? So these two events are dependent. Got it? Mathematically, we say that two events E and F are independent if the probability that they both happen is the product of the probabilities that each one happens. Okay, I'll repeat. Mathematically, we say that two events E and F are independent. When can you say that? That is, if you say E and F are independent, if the probability that they both happen is the product of the probabilities that each one happens. Okay, so probability of E comma F is equal to probability of E into probability of F. In the example above, the probability of first flip head. Okay, so we know that the probability of occurrence of head is 1 by 2, and the probability of both flips, okay, tail is 1 by 4. But the probability of first flip head, and both flip tail is 0. Okay. Now we'll see an example. So take this air traffic data. So let us consider set of observations recorded in the database regarding the arrival of airplanes in routes from any airport to New Delhi under certain conditions. Okay. So this is the air traffic data which is observed. So for example, the attributes are days, season, fog, rain, and based on that you have to decide. Okay, so this is the class we wanted to decide. Okay, this is the class we wanted to classify. So what are the possible classes? The flight may occur on time, late, very late. Okay, so these are the three classes. So these are the three class labels. What are they? On time, late, and very late. So what are the other attributes? So based on this attribute, actually this class is decided. So these are the attributes. So they have mentioned 4 attributes: days, season, then fog, okay, then rain. So about the days, either it may be a weekday, that is Monday to Friday, or it may be a Saturday or Sunday or holiday. Okay, so these are the possible values for days: either weekday, holiday, Saturday, Sunday. And season, spring, winter, summer, autumn, that 4 season. Then fog, none, high or normal. So these are the values, okay, for the attribute fog. And for rain also it is none, slight, okay, and heavy. So these are the values it can be. When you see this particular record, first record, okay, so if it is a weekday and the season is spring and there is no fog and no rain, okay, so the observation is the flight arrives on time. Okay, the flight arrives on time. Okay, and so similarly, if we have totally how many records we have? 3, 4, 5, 6, 10 observations, 10 records we have, right? And here also we have something. Okay, so I think totally 20 records we have. Okay, so in this database there are 4 attributes, that is day, season, fog, and rain, with 20 records or tuples. And the categories of classes are on time, late, very late. One more thing is also there in the thing, that is cancelled. Okay, so cancelled is also there. So given this is the knowledge of the data and classes, we are to find most likely classification for any other unseen instance. For example, I am telling that, okay, so it's a weekday, winter season, high, and that is fog is high, there is no rain. Okay, in that case I should predict the class, whether the flight will arrive on time or late or very late or will be cancelled. Okay, so this has to be predicted. When you see this weekday, winter, high, none, this combination is not there in the given observation. Okay, so this combination is not given in the given observations or given data. Okay, so weekday, winter, high, you can't see here. Okay, so weekday, winter, here this is normal. Okay, but in the that is in the query it is actually high. Okay, so here also we have some data, but here this is none, slide. So the same combination is not there. We are going to give a that is a new unseen instance is given. In that case you have to predict. So the classification technique eventually to map this tuple into an accurate class. Okay, so now we'll see how to do this using this Bayes theorem. Okay, this Bayes theorem also is not new to you. Already you might have studied in your probability and statistics. Okay, so that mathematics from school days you might have learned this. Okay, so what this Bayes theorem says? Bayes theorem gives the conditional probability of an event A given another event B has occurred. Okay, so here what do you mean by this P of A bar A? That means probability of A on occurrence of B. Are you able to understand? So how to read this? Probability of A on occurrence of B. So what is the formula for that? That is probability of B on occurrence of A into probability of A divided by probability of B. Okay. So please remember this. Okay. So based on this only, we are going to solve this Bayes theorem or this Bayes algorithm. Okay. So probability of A on occurrence of B. So this probability of A depends on the occurrence of B, right? So that's why we call that as conditional probability. Okay, conditional probability of A given B. And probability of B on occurrence of A. This is also conditional probability. So conditional probability of B given A, okay, or occurrence of A. And this P of A, P of B, very simple, probability of A and probability of B. Okay, now we'll see. So this probability of A and probability of B are called prior probabilities. Okay, probability of A and probability of B, that we call it as prior probabilities. And this conditional probabilities, no, that is probability of A given B or probability of B given A are called posterior probabilities. Okay, so now we'll see what we mean by this prior probability as well as posterior probability. Example, so we'll see this. So prior versus posterior probabilities. See this table, we have two attributes, X and Y, right? We have two attributes, X and Y. And for X, some values are given, and for Y, some values are given. And this table shows that the event Y has two outcomes. Okay, event Y has two outcomes, A and B, which is dependent on another event X with various outcomes like X1, X2, X3. Okay, so what are the values for Y? A and B. And that A and B depends on the outcomes of X1, X2, and X3 of X. So for example, you just consider case 1. Suppose we do not have any information of event A. Okay, suppose we don't have any information of the event A. Then from the given sample space, we can calculate P of Y is equal to A is equal to 5 by 10. Okay. So how will you calculate? How many records are there totally? How many records are there? See, for example, now I wanted to find out the probability of A. Okay, I wanted to find out the probability of A. You forget about this attribute X. Okay, only based on Y if I have to decide. Okay, so I wanted to know the probability of A. So totally how many records are there? 10 records are there. So how many A's are there? 1, 2, 3, 4 and 5. So what is the probability of A? That is 5 by 10. That is equal to 0.5, right? 0.5. But at the same time, okay, I wanted to find out the probability of A, okay, the probability of A, okay, based on the occurrence of something. Okay, so now here, see, here I am calculating, I wanted to calculate the probability of X2. Okay, the probability of X2, okay, given Y is equal to A, given Y is equal to A. So here actually, here also X2 is there, but it is B. Okay, so you need not consider this. Okay, and here actually we have X2, but Y is equal to B. So this also you need not consider. Okay, so the probability of X2 given Y is equal to A, given Y is equal to A. So only this 2 you have to consider. Okay, so what is that? That is equal to, so how many occurrence of X2? Only 2, right? Only 2. And how many occurrence of A here? That is 5, right? So what is the probability? It is 2 by 5, which is equal to 0.4, right? So how to denote that? P of X2 bar A. Okay, so P of X2 bar A. That is, here they have mentioned X is equal to X2 and Y is equal to A. What it means? Probability of X2 given A. Okay, probability of X2 given A. So now you try to calculate the probability of X2 given B. Okay, probability of x2 given b. So the same thing, because 2 occurrence, right? x2 is 2 occurrence, so 2 divided by b is also 5, so that is equal to 0.4. Got it? Now we'll calculate the probability of x1. Okay, probability of x1 given a. Okay, can you tell me what is the value for that? So x1, this one we have to consider, this one we have to consider. So only 2, right? Again, this is also 2 by 5, that is equal to 0.4. Got it? So this is how we calculate. So this we call it as posterior probability. Okay, this we call it as posterior probability. At the same time, simply if I wanted to calculate the probability, okay, if I say I wanted to calculate the probability of x1, okay, nothing is given here. So what is the probability of x1? 1, 2, 3. So that will be 3 by 10, which is equal to 0.3. Got it? So this is your prior probability. But if you say probability of x1 given some other event, okay, so that we call it as posterior probability. Got it? So now we'll see. So this is your Bayes theorem, same formula. Okay, the same formula, only notation has changed. Okay. So P of, in the previous case, we have mentioned that as A slash B. That's all. Okay. So instead, here they have mentioned as C, comma X. That's all. Okay. So this we call it as posterior probability, and this is the class prior probability, and this is the likelihood of occurrence, and this is the predictor prior probability. Okay. So please note it down. Probability of C on occurrence of X, because I wanted to predict this class C on occurrence of X. Are you able to understand? So probability of C is the class. Okay. So probability of C when A occurs, when X occurs, okay, or given X, that is equal to probability of X given C into probability of C divided by probability of X. So this we call it as predictor prior probability, and this is the class prior probability. Okay, so what I said, if you calculate the probability, that is the prior probability, right? Here also this is prior probability, and we wanted to predict this class, so this is class prior probability, and based on this only we are going to predict, based on X only we are going to predict this class C. So this is the predictor probability. Okay, and this is the probability of likelihood. Okay, so P of C bar X, okay, C given X is the posterior probability of class, that is the target, given the predictor, that is the attribute. And P of C is the prior probability of class. P of X given C is the likelihood, which is the probability of the predictor given the class. And what is P of X? That is the prior probability of predictor. Got it? Now we'll see how to calculate this using a single attribute. Sometimes we wanted to consider more than one attribute. Okay. Okay. So first we'll see a simple thing, that is in case of a single feature. Okay, Navy Bayes classifier calculates the probability of an event in the following steps. So the first thing what it does is it calculates the prior probability. Okay, it calculates the prior probability for a given class label. Okay, in our example, so we have 4 class labels. Okay, we have 4 class labels. So what are they? On time, okay, late, okay, very late, and cancelled. Okay, on time, late, very late, and cancelled. So what you have to do, first you have to calculate the prior probability of class labels. Okay, so that means you have to calculate the probability of on time. Okay, then you have to calculate the probability of late, calculate the probability of very late, calculate the probability of cancelled. Okay, And then you have to find the likelihood probability. Okay, then you have to find the likelihood probability. What is that? Probability of class C on occurrence of X. Then you have to calculate the probability of C on occurrence of X. So that we call it as likelihood attribute. Okay, so probability of likelihood probability with each attribute of for each class. Okay, for each attribute. So for different values of X, okay, for different attributes, okay, you have to calculate the likelihood probability. So then what is step 3? Put these values in base formula and calculate the posterior probability. Okay, you have to calculate the posterior probability and see which class has the higher probability, and so based on the probability value we decide it belongs to which class. Okay, so which class has the higher probability given the input belongs to that higher probability class. Got it? Very simple. Please listen carefully and also please note down these records, these tables. You please note it down so that it will be easy for you to understand. Okay. Please note down these values. Okay. So for this, we are just creating the frequency table. Okay. So we are creating the frequency table for that. That air traffic data, please try to remember that I will post it as an quality assessment in your Google Classroom, and you are supposed to calculate and come. Okay, so for simplicity, so though that record contains 20 tuples. Okay, so for our easy access, because I already I have told you about what are the algorithms we have discussed so far? Decision tree. In decision tree also we have discussed with this outlook, temperature, humidity, windy, etc. Right? So the same thing will take here also. In that case, it will be easy for us to understand. Okay. And now, how many records are there? 3, 6, 9, 14 records are there. Okay. So 14 records are there. Now based on that, so which is our class label? This is our class label. Okay, so based on these attributes, 4 attributes we have: outlook, temperature, humidity and windy. So based on this you have to decide. Okay, you have to predict, okay, whether they will play or not, they will play golf or not. Okay, and so here whether they will play golf or not, so for that we are writing first attribute we are considering. Okay, so we are just taking this. So under outlook, 3 values are there: sunny, overcast and rainy. Okay, so under sunny, how many S is there? So under sunny we have 3 yes. Okay, under sunny we have 3 yes and 2 no. Okay, under sunny 3 yes and 2 no. And similarly overcast 4 and rainy 2 and 3. Whether the values are correct? Under sunny, so this is 2 no. Then here also sunny. Whether the values are correct or not? Tell me. Whether the likelihood table is correct? Yes or no? Are you able to understand what I am talking? Whether this frequency table is correct based on this. Yes or no? Nobody is listening? I'll call randomly. Please answer. Chris, 113. Are you there, Chris? Chris, are you there? So you're not there. So I can mark absent for you, right?
Ma'am?
Okay. Are you there?
Yes, ma'am.
Okay. Now, are you able to see my screen?
Yes, ma'am.
Yes or no? Okay. So I have told you how to calculate this probability, right? So this is the table. So under Outlook, three values are there: sunny, overcast, and rainy. And here we have mentioned how many yes and how many no. Is it correct or not based on this table? Yes, tell me. Yes, Chris, is it correct or not? How many yes is there? How many yes? Hmm? See this table and tell me. 9
Ma'am,
yes is there, huh?
9 out of 10.
So 14 there. How many yes? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 yes. And how many no's? 5 no's, right? I'm asking under sunny. Now you have to check for sunny. Okay. So so consider only this sunny, the attribute sunny, the values for sunny. So under that, how many yes and how many no's? Under that, how many yes and how many no's? Just tell only for
Ma'am,
sunny.
2 yes and 3 no's.
Actually this value is not correct. Okay, so how many yes? 2 yes and 3 no, right? Okay, similarly for overcast, you just tell me. So for overcast, everything is yes, right? For overcast, everything is yes, and there is no, so we have mentioned 0. Similarly, you just now check it for rainy. Okay, so now you just check it for rainy. So under rainy, how many yes and how many no's? Actually, you have 2 yes, right? I think
Ma'am,
3
3 yes,
yes.
2 no's.
3 yes and 2 no's. Okay, so here actually you have 3 yes and 2 no's. Got it? Okay, so this is our frequency table. Okay, for Outlook, for the attribute Outlook. Okay, and so now here actually we have been from the frequency table, we are just calculating the likelihood table. Okay, we are calculating likelihood. So that is probability of X, okay, given the condition C. So for example, probability of sunny, okay, given yes. So here, how will we calculate? So this is actually, this is, you please note down this as 2. Okay, so this is 2 by 9. Okay, this is 2 by 9 and this is actually, so for yes, this is 2 by 9. Okay, and this is actually 3 by 5. And this is correct. Here also this is 3 by 9 and this is 2 by 5. Okay. So now tell me, so how to calculate this probability of X given given C, that is probability of sunny given yes. Okay, so what is the probability? That is equal to 2 by 9. Okay, what is that? Calculate the value and tell me. Calculate the value and tell me. Two by 9. What is the value of 2 by 9? What is the value of 2 by 9?
I'm 0.23.
Yeah, 0.23. Okay, 0.23. Good. Okay, so Here this is the conditional probability, but if you calculate the probability of Sunny alone, that is correct. Okay, so total 5 Sunny out of 14. So that is 5 by 14, that is equal to 0.36. Okay, and here actually you have to calculate. So 2, 4, so how many yes is there totally? 9. So there is no change. So the probability of yes is 9 by 14, that is equal to 0.64. Got it? So how many yes totally? Because since here 2 plus 4, 6 plus 3, 9. Okay, totally 9. And here it is 5. 5 no's. So the probability of yes is 9 by 14. So how will you calculate the probability, posterior probability? So probability of C given X is equal to P of S. Okay, given Sunny is equal to, so instead of this, okay, so this actually, this is this P of Sunny. Okay, what is the formula for this? Okay, so for calculating this, the formula is probability of Sunny given yes, okay, into probability of yes, okay, divided by probability of Sunny. Okay, probability of Sunny. So this is the formula, right? So what is the probability of Sunny given yes? This we have calculated here. Okay, so that is 0.23 into what is the probability of Y? The probability of Y is actually, that is the probability of X, right? So that is 0.64. This is correct. Okay, divided by, so here you have to give the probability of Sunny. The probability of Sunny is 0.36. So what is the total value? Now you just tell me. Multiply 0.23 into 0.64 divided by 0.36. Tell me the value. Make it fast. That is 0.23 into 0.64. Okay, divided by 0.36. What's the value? Yes, tell me. It is 0.408. Okay, so this is the value. So for this, similarly, you have to calculate for all other things, and based on that, you will decide, okay, what is the occurrence. So that we'll discuss in the next class. Please note it down. Okay, so the remaining things we will discuss in the next class. Okay. Now I'll stop sharing this.